I wanted to offer a few comments about the last homework question for this week's assignment about the two-step process. It describes something where we are told what the initial pressure and volume of a particular ideal gas is, tells us what the state of it is, and then tells us information about the final state. And so if we sketch this out on a PV diagram to kind of look at it a little better, it tells us that the initial pressure, whatever your initial pressure is, initial volume is somewhere up in this area here, and that the final, so this is pressure and this is volume, the final volume and pressure are somewhere down below here, okay? When I was in class and talking about how this is in some ways similar to an X and Y plot, the main purpose of that was to accentuate that there are certain values for which we can simply figure out what the change in these quantities are. So here we have some initial state and we have some final state. And if we want to know something about the change in pressure or the change in volume, perhaps the change in temperature, or even the change in internal energy, it should be clear that if we have a delta, if we have a change in something, that we can always know what those changes in values are if we know enough information about the initial and final states. Because by definition, anything that has a change in something means that we take the final value of that something, the change in internal energy, for instance, is simply the final value of the internal energy minus the initial value of that internal energy. It doesn't matter what the thing is, we can always describe it. It doesn't matter how it gets from this point to that point. For certain values, those are the state functions. There are other values where we can't rely on a final and initial value. We talked about some of those the past few days, but it perhaps didn't get stressed quite enough. Two of those are things like work and heat transfer, right? We cannot simply write something that says, oh, work, the change in work is equal to work final minus work initial. Nor can we say that the change in heat transfer is equal to the heat transfer final minus heat transfer initial. These don't work at all because you can't write those expressions because you can't describe what the work is at a particular point. You can't describe what the heat is at a particular point. You can only talk about what the energy is. And the heat transfer, or the work done, depends on how it goes from one side to another. So we can demonstrate that as we try to solve this particular problem. Okay? And I'm going to go through most of the steps of this to show you how that's helpful. I'm going to stop it here so we can start up another video.